Morning, everyone. At this point, you should have received two packets. One should be a single sheet of paper that has a couple of shapes on it with a little grid, and the other should be a little packet named Classify and Identify Regular Polygons. If you don't have either of these, please come up and get one. So what I'd like to do today is start by defining the word polygon. And before I tell you what it is, I'm going to tell you what it isn't. It is not a shape that's, say, a circle, or a shape that has an arch, or any shape that does not have straight edges. Even a shape that isn't fully closed is not a polygon. So with that said, what is a polygon? A polygon is any 3 sides or more, a shape that has 3 sides or more, 2 line segments meet at one vertex, and the shape must be closed. So what does that mean? Well, if you take a look at this little drawing, all of these, assuming I'm drawing straight here, let me try this instead. Say I'm trying to draw a shape. We have 1, 2, 3. Now all the sides are straight edges, and there are 3 sides. If you notice, here's a vertex. There's 2 line segments that meet, 1 and 2. Here's another vertex right here, and 2 segments meet, 1 and 2. But this rule here, 2 line segments meeting at a vertex, is broken because here there aren't 2 line segments that meet at this vertex, and the same thing here. There aren't 2 segments. And also the last rule says the shape must be closed. The shape is open, meaning from here to here isn't closed off. So for that reason, the example I just showed you would not be a polygon. So anything starting with a triangle or bigger would be considered a polygon. Okay, so take a minute, be sure you write this little definition down, and we're going to start classifying and finding some angle measures of polygons. So all of you should have this handout, and what we're going to do, the goal with this sheet, is to come up with a rule or a pattern or essentially a formula as to how we can remember the total degree measure for each of these shapes without having to memorize a list of shapes, their names, and how much their degree measure is in sum. So we're going to go through this sheet. We're going to figure out the number of sides, the number of triangles in the shape, and the total degrees. So how many sides does this shape have? I really hope we're saying 3. And how many triangles is a triangle? Well, this is one triangle. And a triangle measures how many degrees? 180. We all know this, right? Degrees. So let's take a look at the square. The square can be made up, I can pick any one of the 4 vertices. Vertices is plural for vertex. And what I want to do is cut a diagonal in it to create triangles. Now when you do this step, you notice how I have one line going through there? Students are then very anxious to draw another line this way. Please do not do that. When you draw a line to create triangles in a shape, do you notice how the green and the red line intersect? Well, in order to determine how many triangles a shape is made up of, the lines cannot intersect one another. So if I start at this vertex again, I can't go to this vertex because it's not going to make a triangle, and I can't go from this starting point again to this vertex because that's not going to make a triangle. So how many sides do I have in this shape? Oops, wrong color. That's okay. I have 4 sides. How many triangles do I have? 2. So I know one triangle measures 180 degrees. So what would 180 times 2 measure? And you can use your calculators if you need, but I'm sure all of you know any four-sided shape measures 360 degrees. So with what you just learned, let's go to a shape with 5 sides. What do we call a shape with 5 sides? I hope you're saying pentagon, P-E-N-T-A-G-O-N, pentagon. Right, let me just slide this over here for you. Okay, now what we're going to do is, I like to start at the top vertex, and I'm going to cut triangles into this shape. So from here, if you just watch a second, I can't draw a line to this vertex because it's not going to actually make a triangle. So from this top, I can go here, and I've just made a triangle in here. Back to the same vertex, I can go to this next vertex here, and I've made a second triangle, and this third one naturally forms in here. So a pentagon is a shape that has how many sides to it? 1, 2, 3, 4, 5. So a pentagon is a 5-sided shape. And how many triangles were we able to produce on a 5-sided shape? 3. So in conclusion, if I know one triangle is 180, this triangle is 180, and this triangle is 180, I can take 180 degrees for one of those triangles and multiply it by 3 to account for all 3 of the triangles. So 180 times 3, 540 degrees. So far, do you notice number of sides is 3, number of triangles is 1. What's the difference here? 3 minus 2 is 1. How many sides to this shape? 4. So how many triangles can it make? 2. What's the relationship? 4 minus 2. Are you starting to see a pattern? How many sides to this shape? 5. So how many triangles make up a 5-sided shape? 3. 5 minus 2. So beneath us here at the bottom, we have what kind of shape? Let's count the sides. 1, 2, 3, 4, 5, and 6. We have a 6-sided shape. So what do we call a 6-sided shape? Anyone know? It's called a hexagon. Okay? So in this hexagon, we're going to cut some, let me just move that title. Sorry about this. All right, we're going to cut triangles. Remember, when you cut triangles, the lines that you're making cannot overlap each other. So if I start at this vertex, could I go straight down here? Hopefully you're saying no. So from here, I'm going to go straight down to make one triangle. Go back to the same starting point, and you can start at any vertex around the shape. I'm going to go to the next vertex to make the second triangle. How many triangles do you think I'll make? Take a guess right now. Shout it out. Well, let's see if you're right. Go back to the same vertex. Draw another triangle. Here's 3. And if I were to go back to this vertex, I cannot draw a line here because it doesn't actually make a triangle. So I get 4 triangles. So how many triangles do I create? 4. Do you see a pattern again? Number of sides minus 2. How do I find the total degree measure? I take 180 degrees times 4. And what is 180 times 4? I hope we are all saying, let me just double check real quick, 720 degrees. Okay, please make sure all this information is written down as we continue this lesson. Let's take a few minutes. Turn your worksheet that we just completed over, and here are just some additional shapes that you should know the names to them. A 7-sided figure is called a hexagon. An 8-sided figure is called an octagon. A 9-sided figure is called a nonagon. A 10-sided figure, we should all know this, root word deca, decagon. 11-sided figure is called un for 1, deca meaning 10, so un decagon. And 12-sided figure is called do meaning 2, decagon. What I did wrong here. Okay, so there we have it. So let's take a look at this chart. Turn your paper back over. And this is all the information that you should have written down. Can we write a formula to help us find the total degrees for any sided polygon? So if I said I had a polygon that was 10 sides, instead of drawing a 7-sided figure and then an 8-sided and continue this chart, is there a formula that we can produce without having to draw a chart such as the one in front of us? So think about it. The number of sides to find the number of triangles, what do I subtract? 2, correct? So number of sides, n, minus 2. And n represents, let me just type this out. N is the number of sides. So we have the number of sides. Why is this not erasing? We have the number of sides minus 2. And once I know how many triangles this creates, what do I do with that number? I multiply it to 180 degrees. So let's try this. Say I had a 7-sided figure. I have 7 sides minus 2. What's 7 minus 2? Hopefully all of you are saying 5. I'm going to take 5 and multiply it to 180 degrees. So take your calculator and do 180 times 5, and hopefully you come up with a solution of 900 degrees. Now remember, 900 degrees is for a 7-sided figure called a what? Hopefully you're all saying hexagon. All right, guys, I hope you enjoyed the video. See you next time.